Assalamu alaikum warahmatullahi wabarakatuh. Today we're going to discuss and explain the Regent for June 2019 for chemistry. We are in part C. The first question in part C, he gave me an experiment during laboratory activity. I'm not going to read it. I'm going right away for question number 66. Write a chemical name for the compound that decomposed. Decomposed means break breakdown. So I'm looking for which one is going to break down. So means I have to go backward. Here I have an equation showing me that this material is decomposed. Now I want to know the name. I know that K is potassium. Potassium. The problem is for ClO3. ClO3 is a polyatomic ion. So I'm looking for polyatomic ion ClO3, which is chlorate. Here it is chlorate. So I'm going to write potassium chlorate. Okay, so the material name that decomposed is potassium chlorate. And now I ask question number 66. Question number 67, based on the label data, show numerical setup to determine the number of the moles. If you're looking for the reference sheet, last page, okay, number of moles, here it is, okay, number of moles equal to given mass over gram formula. Okay, now I'm going to see. So he asking about number of moles and you want only the setup, so he doesn't want the answer. So for oxygen, the given weight is 0.8, so 0.8, and the molar mass is giving to me 32. Okay, so that's the setup. Question number 68, based on the lab data, determine the mass of potassium chloride produced in the reaction. So now I'm going to see the data. So that's empty, crucible and cover. Here is empty, crucible, cover, and ClO3. So no, he asking about chloride here. So the weight here, if you see crucible, cover, and potassium chloride, here is empty, crucible, and cover. So if I subtract, I'm going to get the mass for potassium chloride. So that's 732.1, 1.27 gram. Question number 69, balance the equation and using the smallest whole number coefficient. Okay, now to balance the equation, I have rules. I start with oxygen, balance the oxygen, after that the hydrogen, but if it's only one side. Okay, so here I balance the oxygen here is 2 and here is 3. So the least common multiple is 6, so I have to say 3O2 to make it 6, and over there is going to be 2 KClO3. Okay, so now I'm going to change the numbers. Here I'm going to write 3. Here I'm going to write 2. So what happened here? I have 6 oxygen. Now I'm going to balance the potassium. So I have 2 potassium 1. I'm going to write here 2. Now I have 2 chlorine, 2 chlorine. Now I balance it with the least coefficients. Question number 17. States a significant number used to express the mass of hydrogen carbonate. Where is the hydrogen carbonate? Here is the hydrogen carbonate. If you don't know it, you can go for the polyatomic ions on page 2. And if you're looking there, here is a hydrogen carbonate. Here is a hydrogen carbonate. Now, how many significant number here? I have a decimal point, so I count starting from the first significant numbers. 1, 2, 3. So 3 significant numbers. 3 significant numbers, okay? Question number 71. Based on table F, which write the formula of the ion in the bottle water table that would form the least soluble compound when combined to sulfate. Sulfate, here is a sulfate. So it can be this one because two negative can't be together. So I have to compare potassium, magnesium, and calcium with sulfate SO4. And I'm looking for the table F, ABCD, table F. I'm looking for the sulfate. Sulfate is here. It's soluble compound and the exception when combined to silver, calcium. So the calcium is insoluble. So it's going to be the calcium one. So everything is soluble here except silver, calcium, selenium, beryllium, and lead. And here for these materials I have calcium. Okay. So a numerical setup to calculating part per million of sodium ions in 50 gram of the sample of bottled water. So he wanted the formula for the part per million. Part per million. First, I have to know dissolved in 50 gram sample water. Okay. So over there, I used the reference sheet part per million. Part per million here. So that's the formula I'm going to use. Mass of a solid divided by mass of solution times a million times million. Okay. So he wanted a numerical set for the ion. The ion mass is 0.0033 over the whole solution is 500. Here is the mass times a million. That's the numerical setup. Now compare the radius of the ion. So if you're looking there, reference sheet, magnesium is 282. Magnesium plus 2, so these two cancel, so 2. So what happened here? It lost one shell, so the radius for Mg ion is going to be less than the radius for the atom. Okay. Question number 74. Now, organic compound. So he asking you what's making it organic compound? Always carbon. Always carbon. Don't forget this one. Write empirical formula. So first I have to write the molecular formula. So I have CHO. How many carbons do I have? 1, 2, 3, 4, 4. How many hydrogen? 1, 2, 3, 4, 5, 6, 7, 8. How many oxygen? 1, 2, Now the empirical formula I have to simplify it, so it's C2H4O. The name of the class, so where is the functional group here? C double bond O, no, and here I have R and there I have R. So I go for the reference sheet and see which one, C double bond O, or that's ester. So I go here, the group is ester. Okay, determine the number of electron sharing between hydrogen and carbon. So here we know that the carbon has 4 electrons in the valence shell and hydrogen has only 1. Okay, and here it's attached to another carbon. So here if you're looking, I have 1 pair or 2 electrons. Question number 78, state the purpose of the salt bridge. The salt bridge keep the migration of the ion. Keep migration of ion. So it's going to be sure that the ion are going to move. Balance is the equation. Write a balanced have equation. Okay, for magnesium. So magnesium before was magnesium, and after that it's Mg plus 2. That's 0. So here I have it should be negative 2. Okay, so Mg0 giving me Mg plus 2. So I balance with the electron negative 1, but here it should equal to 0. So I'm multiplying it by 2. So that's the balanced equation. Explain in terms of electrical energy how electrolysis reaction differ than the voltaic. So in the voltaic, I use chemical reaction to generate electricity. But in the electrolytic, I use the electric energy, and I move it to chemical. Question number 81. Determine the pH. So here I have to read. In the investigation of hydrochloric acid solution with a pH of 2, you wanna determine the pH value that's less is 10 times less acidic than the HCl. So here is the hydrogen concentration. If the pH is 2, so the hydrogen concentration is negative 10 to the power negative 2. And to be less, it should be, I divide by 10, it's 10 to the power negative 3. So this is a new concentration. And in that case, the pH is going to be 3. So the answer is 3. Say the color of bromochromazole, bromkerizole green, KOH is base. So I'm looking for the reference sheet, bromkerizole green, bromochromazole green here. So the bromochromazole green, it's yellow and acidic, and blue in base. And in that case, it's going to be blue because the KOH is a base. Complete the equation in your booklet. Because I don't have the booklet, I uh, I have the test there. Okay, give me. Oh, here is the equation. So what's going to happen here? That's acid. That's base should give me water. So H2O and salt. So I get the OH and the H. So I have KCl. So that's the equation. Okay. Show numerical setup to calculate the molarity. So in that case, I'm doing neutralization. So the neutralization rule is over there. mass of acid times volume of acid equal to mass of base times volume of base. Okay, so I get the setup. I'm going over there. You wanna the molarity for the base, so the molarity for the base equal molarity of the acid times volume of the acid divided by volume of the base. Now I need this information. So now the pH, so the molarity of the acid. So here the molarity of the acid is, here is the acid. So 0.01 times the volume of the acid, which is 15, and it took the volume for the base is 7.5. So if I do this setup, I'm going to have it, which is 0.02 molar. Now, explain in terms of aqua ion. So when it's 1 molar, it has more ions, and more ions means more electricity because the migration of electrons and ions is responsible for the electricity current. Hope you understood and have a good day. Assalamu alaikum wa rahmatullahi wa barakatuh.